Okay, so let's do another application problem where we're going to read this and then we're going to express one variable as a function of another variable. And so if we look at this, it says a metallurgist melts and mixes m grams of solder, that is 40% tin, with n grams of solder, that is 20% tin. And they get a final mixture that is 200 grams of solder. We want to express n as a function of m. So we want to write n as a function of m. So we want to get n equal to the rest of it. Okay, so first of all, we need to set it up. And so what do we know? Well, we know that we have m grams that is 40% tin. Hold on a second. Let me make sure I'm getting this right. Oh, sorry. This is 200 grams of tin. I knew I was missing something. Of tin. Okay, so we know that m grams of this solder is 40% tin, so he's melting it down. Okay? And then he's taking another n grams of solder that is 20% tin, and he's melting that down. And so he's mixing the two together. Okay, so how much tin, how do we calculate the amount of tin in here? Well, 40% of the m grams, keyword of, is tin. So this is a multiplication, right? So if I want to express the amount of tin, the amount of grams of tin that I have, I'm going to multiply the m grams of solder times the 40%. Okay, so that means 0.4 m, that's going to give me the amount of tin in that amount. Plus, same thing here, 20% of tin of the n grams. So I'm going to take 0.2 times n equals the final 200 grams. So now I'm done, because now all I have to do is solve for n. So first thing I'm going to do is I'm going to subtract 0.4 m, right? I got to isolate the n variable. So I'm going to start with the addition here. So I'm going to subtract off 0.4 m. Okay? Actually, you know what? Before I do that, why don't I do this? Why don't I just multiply everything by 10 and get rid of the decimals? There's nothing wrong with doing that. So let's just multiply everything by 10. So if I multiply everything by 10, this becomes 4, this becomes 2, and this becomes 2,000. There's nothing wrong with doing that. I'm not changing anything, because remember, as long as you do the same thing to both sides of the equation, you don't change the equation. Or more succinctly, you don't change the solution set. Okay? So now this is going to be easier to work with. So now let's subtract 4m. So now what do I get? I get 2n equals 2,000 minus 4m. And now I'm going to divide by 2. And so my final answer is n equals what? Well, this is 2,000 divided by 2 is 1,000, minus 4 divided by 2, which is 2m. And there's my function. So f of m equals 1,000 minus 2m. Now, what else do they tell us here? Well, let's talk about the domain. What can I have in the domain? So now this is an application type problem, so you've got to be careful, right? So now let's talk about the domain. So I'm going to erase this. Okay, so we've got the function there. So what's the domain? So in other words, what's all of the values of m? Well, remember m and n represent amounts of solder. Can't have negative amounts of solder, right? So m and n both have to be greater than or equal to 0. But, so that means, right, so this is n. So m is only going to be restricted because n can't be negative. So, what happens to this? Well, m, right? M is greater than or equal to 0, that's true. But can it go off to infinity? Can I have 1,000,000 pounds of solder? No. Because what happens when m is 500? When m is 500, this becomes 0. And what happens if m is bigger than 500? Well, all of a sudden, n becomes negative. So guess what? M is restricted to being no bigger than 500 grams. Okay, good. So now, the range. If n is restricted here, how does that affect n? Well, let's figure it out. Well, when m is 0, n is 1,000. Right? So obviously n is bigger than or equal to 0, right? Can't be negative. But what happens when m is 0? When m is 0, n is 1,000. When m is 500, n is 0. So guess what? There's your range. Okay, have a great day.